students, it's my pleasure to meet you today. I am here, Mr. Abdalnasser Jabir. I am here and my colleagues in Study 12 in our Educational One Egyptian channel. Today we are going to study new lesson in geometry, which is similarity and areas. Now we will draw a triangle like that. If we have two triangles and the two triangles are similar, a triangle A, B, C, and the other triangle which is X, Y, Z, like that. If the two triangles are similar, such that the triangle ABC is similar to triangle XYZ, and what's the relation between these two triangles and their perimeter? As we said before, the ratio of these triangles, like that, AB over XY equals BC over YZ equal AC over XZ. Each ratio equal the perimeter of triangle ABC over the perimeter of triangle XYZ. But now we will study the relation between these ratios and area. The area of triangle ABC over the area of triangle XYZ will be equals any ratio of these ratios but power 2. We can say equals AB over XY all power 2, or we can say AB power 2 over XY power 2. So the ratio between the area of two triangles equals square of any ratio of these ratios. Okay, but when we talk about perimeter, it's equal the perimeter of area, the perimeter of any triangle over the perimeter of the other equals the ratio itself. If this ratio, as example, equal 2 over 1, then the perimeter of triangle ABC to the perimeter of triangle XYZ equal 2 over 1. But when we talk about the area here equal the ratio but squared ratio here, so it will be equal here equal 4 over 1. So the ratio between the area of two similar triangles equal any ratio of its ratios squared. Okay, let's move to an example here. If we have an example, the example says that the ratio between areas of two similar triangles equals 9 to 16. If we have two triangles here like that, triangle ABC and another triangle XYZ, which is bigger than the first triangle. The first triangle ABC, second one XYZ, and the example says that the area of the triangle ABC to the area of triangle XYZ equals 9 over 16. So we have the ratio of the area. Okay, and he gives that the perimeter of the smaller, which is ABC here, its perimeter equals 60 centimeter. Okay, so the perimeter here equal 60 centimeter, and the request is to find the perimeter of triangle XYZ. Solution: we know that the area of triangle ABC equal over area of triangle XYZ equal the square root of the ratio. We know that the triangle ABC is similar to triangle XYZ. So here AB over XY equal BC over YZ equals AC over XZ equal also perimeter of triangle ABC over perimeter of triangle XYZ. But we know that the ratio between the two areas equal 9/16. Of course, here equals, as example, AB over XY. Okay, to find AB over XY here, we must find the square root of 9/16. Why? Because the ratio of area equals AB over XY, which is the one of the ratios of the triangle, but power 2. So to get AB over XY only, we must square root 9/16. So AB over XY here will be 3/4. Okay, so perimeter of triangle ABC, which is 60 centimeter, over perimeter of triangle XYZ equals 3/4, which is one of the ratios. Okay, so to get the perimeter of the triangle XYZ, perimeter of triangle XYZ will be equal 4 multiplied by 60 over 3, and the final answer will be 80 centimeter. Okay, so we now have gotten that the perimeter of triangle XYZ equal 80 centimeter because we used the ratio of area. Okay, the given is the ratio between the two areas 9/16. We take the square root of 9/16 because 9/16 means a power 2 over xy power 2. To get 9/16 inside the ratio square root equals 3/4. So the perimeter of triangle ABC over triangle XYZ equal AB over XY, which is 3/4. And the given that triangle perimeter of triangle ABC equals 60, so we can get the perimeter of triangle XYZ by cross multiplication. We multiply 4 by 60 divided by 3, as we said in primary 6. Okay, let's move to another example here. We have many examples for you to understand, and the more important you to recognize that the difference between the ratio of two triangles which are similar and its perimeter. The perimeters will be the same size, same number, but the ratio between the areas equals the square of the ratio. Okay, let's move to another example now. If we have a triangle like that, we have triangle ABC triangle. and we have a line segment here. Triangle ABC, and we have XY, which is parallel to CB. And the ratio between AX to XB equals 2 to 3. Okay? And the area of triangle ABC, the area of triangle ABC equals 62.5 square centimeter. Okay? And given also that the ratio between AX to XB, as we said before, equal 2 to 3. And the request is to find the area, of triangle of the quad, not triangle, it's quad, which is XBCY. So we have to find the area of this quad. Okay? First, we have to concentrate about the similarity of two triangles. The smaller triangle here and the bigger one. Okay? We have triangle AXY and the whole triangle, which is ABC. And if we try to prove the similarity, it will be easy for us because XY parallel to BC, so we have measure angle AXY equal measure angle B, corresponding angles, and also measure angle of AYX equals measure angle of ACB, corresponding angles also. And we have the common angle A, and we need only two angles to prove the similarity. So we can say the triangle AXY is similar to triangle ABC. And of course, we can deduce that AX over AB, okay, equals XY over BC, also AY over AC. And we know that AX over XB, AX over AB, which is this ratio, equals 2 over AB here equals what? Equals 2 plus 3 ratio, so it's 5. So the ratio between AX and AB equal 2 over 5. Don't make a fault that some people write 2 to 3. No, it's AX over the whole AB, so it's 2 over 5. Okay? And we know if we talk about the area of triangle AXY over area of triangle ABC will be equal 2 over 5 but squared, because we know that the ratio between the areas equals square the ratio or the square of similarity ratio. Okay, now we have the area of triangle ABC, which is the bigger one, which is in the denominator here, equals 62.5 square centimeter. So by substitution, we will get area of triangle AXY over 62.5 equals 4 over 25. Okay? We can get the area of triangle AXY by cross multiplication. We multiply 4 by 62.5 over 25 here, and we will get that the area of triangle XY equals 10 square centimeter. So the area of triangle XY here equal 10 square centimeter, and the whole area of triangle ABC here equals 62.5, and the request is the area of the quad XBCY. The area of the quad XBCY, of course, equals the area of triangle ABC minus the area of triangle AXY. So, the area of quad XBCY equals 62.5 minus 10, which is 52.5 square centimeter. And now we have find the request, which is the area of the quad XBCY. Okay, let's move to another example. The other example is talk about triangle, about a triangle here. So you can draw with me. And a triangle like that. And we have expand for this triangle like that. We have here joining this triangle, and we will join this line segment also. Okay, so we have ABC is an isosceles triangle, and we have measure angle HAB, this angle equals the measure of angle ADC, which is this angle also. So in this figure we have an isosceles triangle ABC, AB equals AC, and also measure angle HAB here equals the measure of angle ADC. Okay, and the area of triangle that's given also. The area of triangle ACD, okay, area of triangle ACD equals 4 times the area of triangle, yes, the area of triangle ABH. We have now a relation between the area of triangle ACB. Where is the triangle ACB here? The triangle ACB is this, ACD is this one, equals 4 times the area of triangle ABH, which is this triangle. So we can say that the ratio between the area of triangle ACD over the area of triangle ABH equals what? Equals 4 to 1. It's vice versa. When we say that the area of triangle ACD equals 4 times the area of ABH, then when we write the ratio like this, we say area of triangle ACD over area of triangle ABH equals 4 over 1. Here is 1. Okay, so we have now the area of ACD over the area of triangle ABH equal 4 over 1. We have area, but we haven't similarity up till now, so we must prove the similarity to benefit from this information about the area. Okay, we will try to prove that the triangle ACD similar to triangle ABH. What the given for us? Here we have AB equals AC from the beginning, because ABC is a isosceles triangle, which is given. We know from our studying that AB equal AC means that measure angle ABC equal measure angle ACB from the properties of isosceles triangle. And also we know that this angle is supplement to this angle, which is ABH, and we know that the angle ACB is supplement also to the angle ACD, and we know the supplements are equal when the angles itself are equal. Okay, because the sum of these two angles 180, and the sum of these two angles also equals 180. So when the angle measure angle ABC equals measure angle ACB, then we can deduce that measure angle ABH equals measure angle ACD. And from the given, the measure of this angle, which is HAB, equal the measure of this angle, which is the angle ADC. It's enough for us to prove that the two angles in the two triangles are equal, to prove that they are similar. So we can say now that that triangle ACD is similar to triangle, and concentrate about the corresponding points or vertices. We know that the angle here on C equals the angle here on B, so C is corresponding to B, and we know also that the angle A in the second one is equal D, so A here is equal D. And we have the triangle ACD and this triangle HBA. So the triangle ACD is similar to triangle HBA. And from this similarity, we will deduce that AC over HB equals CD over HA or H equals AD over HA. Again, AC over HB equals CD over BA, and AD over HA. Okay, and we know that the similarity between the two triangles, the ratio of area between the two triangles here will be 4 over 1. So each ratio of this one equals the square of 4 over 1. So we can say that AB over DC or CD over AB here equals square root of 4 over 1. So it's equal to 2 over 1. Okay, and the request is to prove that DC equals double AC. Okay, but we haven't AC here, but we know that AC equals AB from the beginning given. So we can replace AB by SAB by AC. So CD over AC equals 2 over 1. And by using cross multiplication here, CD multiply 1 equals CD, equals 2 multiply AC to AC. And now we prove the request, which is DC equals double AC. Okay, let's review again these two triangles. We have benefit from our previous studying about the properties of isosceles triangle ABC. Measure angle ABC equal measure angle ACB. So measure angle ABH equal measure angle ACD. And we have measure angle HAB equal measure angle D from the given. So we have two angles equal to angles in the triangles ACD and ABH. So the triangle DAC similar to triangle ABH, and we benefit from, okay, and we deduce that these ratios, and each ratio of course equals square root the ratio of the areas. So we have the square root 4 over 1, it's equal 2 over 1, and because we have AB here equal AC, we replace AB by AC, and using cross multiplication we deduce that CD equal twice AC. My dear students, let us take a little break and we will return again. Hello again, my dear students. We have a call from Salma from Alexandria. Hello, Salma.
الو.
Yes, hello.
ازيك حضرتك يا مستر؟
اهلا وسهلا حبيبتي، اتفضلي.
I have a question.
انت في سنه كام يا سلمى؟
أولى ثانوي.
اولى ثانوي. اتفضلي، ليك سؤال ولا حاجه؟
عندي سؤال.
اتفضلي.
The angle.
نعم.
The angle.
The angle ها.
whose measure is negative 850.
سؤال بس، هو السؤال بتاعك في الموضوع بتاعنا similarity and areas ولا حاجه تاني؟
لا، هو في الدايركت انجل.
لا معلش، يبقى بصي ان شاء الله المره اللي بعد الجايه احنا هنشتغل تريج، فارجوكي عشان يبقى ايه، لازم احنا ملتزمين بالبرنامج. النهارده بنتكلم عن similarity and areas، فلو ليكي في السؤال
similarity of polygon.
نعم،
كان عندي سؤال في similarity of polygon.
طب اتفضلي.
polygon ABCD.
بوليجون ABC.
ABCD.
لا مش سامع الصوت.
ABCD.
بوليجون ABCD. اوكي.
Its similarity to polygon XYZL.
XYZL. اتفضلي.
AB equals 32 centimeter.
AB equals 32. ايوه.
وBC equals 40 centimeter.
BC 40 centimeter. Right.
XY equals 3M minus 1.
XY equals 3M minus 1.
3M minus 1.
اوكي.
YZ equals 3M plus 1.
لا بالراحة تاني كده.
YZ.
مش سامع. again.
YZ.
YZ ايوه equal كام؟
3M plus 1.
3M plus 1. اتفضلي.
عايز الفاليو بتاعت M.
عايز ايه؟
الفاليو للM.
حاضر عينيا. شكرا سلمى. تابعيني حاضر. بصوا يا ولاد معايا، ده سؤال عن السيميلاريتي اوف تو بوليجونز، وسلمى بتقول ان البوليجون which is ABCD is similar to the polygon XYZL, and we know that when we make this arrangement, then we can deduce that AB over XY, AB over XY equals BC over YZ equals CD over ZL, also equal AD over XL. Okay, AB here is 32, so we can replace AB by 32 over XY here 3M minus 1, so we can replace XY here by 3M minus 1. equal. We have here BC. BC here equal 40 centimeter. So we can replace BC by 40 centimeter over YZ. YZ here is 3M plus 1. So we can replace YZ by 3M plus 1. Okay? And using cross multiplication, we multiply 40 by 3M minus 1. And before multiplying, we can simplify. The numbers will simplify here. Here we have 40 and 32. All of them divisible by 4. So we can divide this one by 4. It will be equal 10. And divide by 4 will be 8. Also 10 and 8 divisible by 2. So divide by 2 equals 5. And 8 divided by 2 equals 4. So the ratio in simplest form here can written by 4 over 3M minus 1 equals 5 over 3M plus 1. طب لو سلمى سألت هو أنا ممكن لازم أعمل السمبليفاي ده أو لا مش لازم، معاك كالكوليتر تشتغلي، بس احنا عايزين نبسط الأمور شوية. طيب تعالى بقى نكمل طريقتنا. بنعمل ايه؟ كروس مالتيبليكيشن here. 4 multiply 3m plus 1. 4 multiplied by 3 equal 12 m plus 4 multiplied by 1 equals 4. Write equal and multiply 5 by 3m minus 1. 5 multiplied 3 equal 15 and it is 15m minus 5 times negative 1 equals negative 5 here. Okay, we have here 12m in the left side and 15m in the right side, and we must transfer 15m here and 4 to be here to complete the equation. So 12m minus 15m equal negative 5, and we will transfer 4 here to be negative 4. Okay, now we have 12m minus 15m equal negative 3m, and we have negative 5 minus 4, which is negative 9. By dividing the two terms here, or the two sides, by negative 3 here and negative 3 here. Okay, so we will get negative 3 cancelled with negative 3. So m equal negative 3 divided negative 9 divided by negative 3, which is 3. So m Salma, so m equals 3. Okay, so we have okay, so now we have answered for Salma's question, which is we have two polygons here are similar. I think the problem of Salma when she saw that xy in a symbolic method, which is 3m minus 1, and yz is 3m plus 1, and we solved it by what? Just say quad ABCD equal similar to the quad XYZL, and we applicate the similarity ratio here equals this one, and AB here equals 32, XY equals 3m minus 1, and also BC equals 40, and YZ equals 3m plus 1, and we make cross multiplication, and when we solve equations we will find that m here equal 3 centimeters. Thank you, Salma, for watching and for calling, for asking, and for caring, because I am happy when we saw about girls and boys in first secondary, which they are care and attend the lessons here. So thank you, Salma. And if you want to call any time in this program, you can call. Okay, let's complete. We have here a circle. Let's draw a circle here with each other. We have a little circle here. Let me clarify it using this pen. Okay, and we have a triangle ABC like that. And expand a little to get another triangle here, but this triangle we have here AD is a tangent, so we have here A, B, C, and this tangent, so we can expand BC to intersect it like that. And this is D, of course. And we have the ratio between AB and AC, AB over AC equals 5 over 3. So AB, its ratio equal 5, and AC, its ratio equal 3. And we have drawn AD as a tangent, okay, to intersect BD at to intersect BC at D, as we said before. The request is to find the ratio between the area of triangle ACD, ACD. We want to find its ratio to the area of triangle ABC, this one. Okay, we have here an example. It's a very simple example, but it depends on the information which we studied before. We know about the tangent here AD, but if you have studied that, if we have a tangent AD here and a chord AC, so this angle will be called the angle of tangency, and its measure equals the measure of an inscribed angle ABC, which subtend the same arc AC. So let us concentrate that the measure of the angle CAD, okay, so we have the angle CAD, which is the angle of tangency, equals the inscribed angle ABC, which is inscribed, subtended by same arc AC. This from our studying in third preparatory last year. Okay, and if you don't know about it, I tell it about you for you now, that if we have a tangent like that, tangent touch the circle at one point, as we see now, touch it at A, and we have a chord, the angle here called angle of tangency. This angle of tangency equal in measure the inscribed angle here, right? The inscribed angle. Inscribed angle because its vertex on the circle and its two sides are chords on the circle. And these two chords intercept or opposite to the same arc of the angle of tangency here. The angle of tangency subtends the arc AC, and the inscribed angle also subtends the same arc AC, so they are equal in measure. So we can say that measure angle DAC equal measure angle B. Okay, and we know that the angle AD here considered is a common angle between the triangle ADC and the bigger triangle, which is the whole triangle ADB. So when we said that this angle equal this angle, and we have a common angle here between the two triangles ADC and the triangle ADB, we said D twice in the two triangles, so the angle D is common triangle between the two angles. So we can say the angle D is a common angle of the two triangles ADC and ADB. So now we can say easily that the triangle ADC is similar to triangle ADB, but careful about the corresponding angles. First, try to write the triangle ADC. We will start with A. This angle equals this angle. So the next triangle, we will start with B because the angle B here equals the angle A. And D is the common angle in the two angles. So can say D here and D here also. What's the rest? We have the angle ADC is similar to triangle BDA. And we can deduce that the ratio between these sides equal AD over BD equals DC over DA equals AC over BA. Okay, so we have now that similarity ratio, this one equals this one equals this one, and we will concentrate specifically on AC and AB because we have them. So we search about AC and AB. Yes, AC and AB or BA here. So equals AC over AB or BA equal 3 over 5. But when we talk about the ratio between the area of triangle ADC to the area of triangle BDA, we must square the ratio because the ratio between areas equals square the similarity ratio. So we can say that the area of triangle ADC over the area of triangle BDA equals 9 over 25. But the request is to find the ratio between the two areas of area of triangle ACD, this one, and the area of triangle ABC, this one, not the whole triangle. So we must subtract the area of triangle ACD from the whole triangle to get the triangle ABC. Where is the triangle ADB? This one. And we must subtract area of triangle ADC. Where is the triangle ADC? It's on the top here, and we must make the same in the numbers. ADC here is 9. Its ratio or its parts equal 9. So we subtract 9 from the denominator here. Okay? Again, to get from the denominator the area of triangle ACB from the whole triangle ADB, we must subtract this triangle which is ADC. Okay? And from the properties of ratio, we must make the same of the numbers, because we here subtract the numerator from the denominator. We will subtract the numerator here from the denominator. So we will get that here is 9 over 25 minus 9 equals 16. So the ratio between the area of triangle ADC over the area of triangle ABC equals 9 over 16. And now we have solved this equation or this question. Okay, let's move to another property about the area and similarity. We have some important notices here about the relation between the area and bisectors of triangle. Edges of triangle are similar. So are they have a relation between their areas and bisectors, the vertex angles, or the medians, or the perpendiculars from this vertex to the base, or so on? Let's concentrate here to get some properties. If we have two triangles like that, first triangle and second one, and we have a median here. Do you know about medians? What is the median of triangle? Remember, the median of triangle is the line segment joined from the vertex of triangle and bisect the base, the opposite base. So if we have triangle ABC here, and we have L here, and this triangle DEF, and M is the midpoint here, and say that the area, the triangle ABC is similar to triangle DEF. So now we will deduce that the area of triangle ABC over the area of triangle DEF equals the median EL but power 2 over the median DM but power 2 also. And we can say that it's equal AL over DM all power 2. So we will consider now that the two medians here equal one of the ratios of similarity of two triangles. So if we have two triangles and they are similar, and we have the side lengths of a median here equals, as example, 6 centimeter, and this one equals 3 centimeter here, and you want to find the ratio between area of triangle ABC over the ratio of triangle DF. AL here equals 6 over DM here equals 3 by squared. then the ratio between the two triangles equal 36 over 9, which is, so yes, 6 times 6 equals 36, and 3 times 3 equal 9. And we can divide by 9 here, equal 1. Divide by 9 equal 4, so it's 4 to 1. From the beginning here, 6 over 2 equals 2 over 1, and we can square it to be 4 over 1. So the ratio between the area of two triangles, ABC to DEF, equals 4 to 1. Now, let's move quickly before we finish about another property, about the ratio of similarity and bisectors of two triangles. So concentrate with me now. If we have two triangles here, triangle ABC, okay, we have two triangles here and another triangle. Now we will talk about the bisector of an angle. So if we have this line segment, but line segment here bisect the angle, and we have another one to bisect this angle. We call ABC for this triangle, XYZ for this triangle, and we have here AN and DZ or XZ. Okay, also the ratio between the area of triangle ABC over the area of triangle XYZ equals the bisector AN over the bisector XD, but squared. So we have the length of the two bisectors here. We can write them here to find the ratio between the two areas. Also, if we have two triangles like that, quickly we can say about two triangles. Okay, and we have this perpendicular line segment and this perpendicular one also. If we say that this triangle is LFM and XYZ also, and this is LO and XB. Okay, so the ratio between the area of two triangles here, triangle LFM over the area of triangle XYZ, equal the two perpendiculars but not squared, LO over XB. Okay, my dear students, we have finished for now, but we can say about if we have two triangles. Okay, if we have two triangles like that and we have the same vertex, this is A, B, C, D, E, and we have perpendicular here X. So the area between the triangle ABC over the area of triangle ADE equals the ratio between the two bases CB over DE. Okay, we have finished now. So my dear students, it's my pleasure to meet you today. Try to study hard and try to solve questions and call us if you want. Goodbye and good luck.